ನಮಸ್ಕಾರ ಮಕ್ಕಳೇ, ವೆಲ್ಕಮ್ ಟು ಕೆಮಿಸ್ಟ್ರಿ ಕ್ಲಾಸ್. ನಾನು ಪುಷ್ಪ. ಸೊ ಡಿ ಅಂಡ್ ಎಫ್ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಮೇಲಿರ್ತಕ್ಕಂಥ ಕ್ವೆಶನ್ಸ್ನ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಇದ್ವಿ. ಇವತ್ತು ಅದನ್ನು ಕಂಟಿನ್ಯೂ ಮಾಡೋಣ. ದ ಫಸ್ಟ್ ಕ್ವೆಶನ್, ಜಿಂಕ್, ಕ್ಯಾಡ್ಮಿಯಂ, ಮರ್ಕ್ಯೂರಿ ಆರ್ ನಾಟ್ ಕನ್ಸಿಡರ್ಡ್ ಆಸ್ ಟ್ರಾನ್ಸಿಷನ್ ಮೆಟಲ್ಸ್ ಬಿಕಾಸ್ ದೇ ಡೋಂಟ್ ಹ್ಯಾವ್ ಪಾರ್ಷಿಯಲಿ ಫಿಲ್ಡ್ ಡಿ ಆರ್ಬಿಟಲ್. ಟ್ರಾನ್ಸಿಷನ್ ಮೆಟಲ್ಸ್ ಅಂದರೆ ಪಾರ್ಷಿಯಲಿ ಫಿಲ್ಡ್ ಡಿ ಆರ್ಬಿಟಲ್ ಇರಬೇಕು. Write the general configuration of D block elements. The general configuration is like this. So n-1 D 1 to 10, ns 1 to 2. ಅಂದ್ರೆ electrons ಗಳು ಪೆನಲ್ಟಿಮೇಟ್ ಶೆಲ್ ನಲ್ಲಿ ಆಡ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ ಫಾರ್ ಡಿ ಆರ್ಬಿಟಲ್. ಅದಕ್ಕಿಂತ ಮುಂಚೆ ನೋಬಲ್ ಗ್ಯಾಸ್ configuration will be there. Noble gas n-1 D 1 to 10, ns 1 to 2. 1 to 10 andre 1 ರಿಂದ 10 electrons vargu it keeps on getting added. What are the factors that decide the ionization potential? So obviously ionization potential is dependent on the atomic size. Okay, so atomic size alde this is also dependent on the bond enthalpy, hydration enthalpy value. So idra melu kuda ionization enthalpy or the potential is dependent. So but mainly we can say it is also dependent on the atomic size of an atom. Smaller the size of an atom, more will be the ionization potential. Yakendre size chikkadidre nuclear charge will be more. So more the nuclear charge, it is very difficult to remove an electron. Hagagi ionization potential ಜಾಸ್ತಿ ಇರುತ್ತೆ. What are interstitial compounds? Give two examples. This is one of the characteristics of D block elements to form the interstitial compounds. Interstitial compounds ಅಂದ್ರೆ ಈ ಮೆಟಲ್ಗಳು ಯಾವಾಗ ಸ್ಪಿಯರ್ ರೀತಿಯಲ್ಲಿ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿ ಅವು ಕ್ರಿಸ್ಟಲ್ ಲ್ಯಾಟಿಸ್ನ ಮಾಡುತ್ತೋ, ಸೊ ಆಗ ಕ್ರಿಸ್ಟಲ್ ಲ್ಯಾಟಿಸ್ ಫಾರ್ಮ್ ಮಾಡುವಾಗ so there will be a voids. Okay, so within these voids smaller atoms like hydrogen, nitrogen, carbon will be trapped. So they are called as the interstitial compounds. Compounds formed by trapping of small atoms like hydrogen, carbon and the nitrogen inside the crystal lattice. So example we can give titanium carbide, manganese nitride. So but idralli these are non stoichiometric in nature. That is the ratio of is interstitial atoms ಏನಿದೆ ಅದು ಕಾರ್ಬನ್ ಇರಬಹುದು, ಹೈಡ್ರೋಜನ್ ಇರಬಹುದು, with that of the metal there is no proper ratio. Okay, so they are considered to be non stoichiometric ratio. But it interstitial compounds ಈ ತರ small atoms trap ಆಗೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ, the properties are completely different. So the hardness increase ಮಾಡೋದಿರಬಹುದು ಅಥವಾ melting point ಜಾಸ್ತಿ ಮಾಡೋದಿರಬಹುದು. At the same time they don't interfere with the metallic conductivity, so they retain the metallic conductivity of the particular metal. These are actually helpful for the metals. Name the two series of F blocks. So F blocks are also known as the inner transition elements. So inner transition elements galu they actually belong to 6th and 7th period of periodic table. So 6th period ನಲ್ಲಿ ಇರೋದನ್ನ ನಾವು lanthanoid series ಅಂತ ಕರಿತೀವಿ, 7th period ನಲ್ಲಿ ಇರೋದನ್ನ actinoid series ಅಂತ ಕರಿತೀವಿ. So which will be having the antipenultimate shell ನಲ್ಲಿ f orbital ಇರುತ್ತೆ. So that is 4f for the lanthanoid and 5f for the actinoid. So because 6 is the period ಅಂತಂದ್ರೆ n is equal to 6, so antipenultimate ಅಂದ್ರೆ last but second, so n-2 ಮಾಡಬೇಕು, so that will be 4f. Similarly for 7th period, that is actinoid series, n is equal to 7, n-2f is equal to 5f orbital. The chemistry of actinoid is more complicated than lanthanoids because actinoids will exhibit variable oxidation states. Lanthanoid alli it is +3 oxidation state except for cerium which will exhibit the +4 oxidation state. Adu bittu ulida ella lanthanoid, that is 13 more lanthanoid elements galenide they exhibit +3 oxidation state, but cerium exhibits +4 oxidation state because it can easily acquire the nearest noble gas configuration. But in the actinoid series, they exhibit variable oxidation state and they are radioactive in nature. Okay, so hence their study would be little difficult. What is the general valence configuration of F block elements? F block element would be this one. So penultimate shell nalli D irutte, antipenultimate alli F irutte, and there will be S orbital nalli kuda electrons add agate. So this would be the configuration. So it is quite difficult or not so easily we can identify, okay, so where exactly the electron is getting added. So what is the most common oxidation state of lanthanoids and actinoids? So as we just now learnt, lanthanoids will be having +3 oxidation states except for cerium. Actinoids will be having the variable oxidation states. Actinoid contraction is more than lanthanoid contraction because of the, so hege ನಾವು lanthanoids ಅಲ್ಲಿ lanthanoid contraction ನೋಡ್ತೀವಿ, ಹಾಗೆ actinoids ಅಲ್ಲಿ actinoid contraction ಇರುತ್ತೆ. So that is 5f orbital. So but the shielding power of 5f orbital is still more poorer than the 4f orbital. What is the composition of Mish metal? Give its one use. Mish metal is the alloy of lanthanoid atoms or the elements. Okay, so it is an alloy of lanthanoid metals. What will happen here, 95% lanthanoid metal will be there and nearly 5% iron and traces of carbon, sulfur, calcium, aluminium. These metals and non-metals will be added to make the Mish metal. That is an alloy, and this is used to make the bullets. Okay, so shells or the lighter flint can be made out of the Mish metal. Actinoids show larger number of oxidation states than the lanthanoids. That is again because of the presence of 5f orbital, 6d orbital and 7s. You can see here how like all the orbitals are there, so where the electrons can be getting added up. So because of the presence of F, D, S available and the electrons are there, so hence it will show the more oxidation state. Next one, explain the following. Generally, there is an increase in density of elements from titanium to copper in the 3D elements. So that is a first transition element ಬಗ್ಗೆ question ಇದು. So ಇದರಲ್ಲಿ titanium ಇಂದ copper ವರೆಗೂ ಹೋಗ್ತಾ ಇರುವಾಗ atomic size ಏನಾಗುತ್ತೆ, decrease ಆಗುತ್ತೆ. So atomic size decrease ಆದಾಗ obviously the density will be more because in the given volume more number of atoms can be added. So more the number of atoms, more will be the density. So the properly you can write from titanium to copper, the atomic size of elements decreases and the number of atoms can be added more in the given volume. So mass will increase, as a result density will increase. So lesser atomic size, more mass, therefore more density. Next one, copper 1 + 1 ion is not known in aqueous solution. So mainly because Cu + 1 undergo disproportionation reaction. Okay, and they are unstable. Okay, this Cu + 1, because they undergo disproportionation reaction and they are unstable in aqueous solution. So because of this reason we don't usually see the Cu + 1 ions in the aqueous solution. So immediately water ಹಾಕಿದ ತಕ್ಷಣ ಅದೇನಾಗುತ್ತೆ, Cu2+ ಆಗೋ copper ಆಗಿ turn ಆಗುತ್ತೆ. So both oxidation and reduction will takes place. Okay, so but converting Cu + 1 ಇಂದ Cu2+ ಮಾಡ್ಲಿಕ್ಕೆ of course more ionization energy is needed because Cu + 1 ನಲ್ಲಿ completely filled d orbital ಇರುತ್ತೆ. So from there to remove the electron, obviously we should give more energy. In spite of that one, since the Cu + 1 undergo disproportionation and it is unstable, so what happens, that will overcome the more ionization enthalpy. Okay, so that is the reason we have got Cu2+ ions more in number than the Cu plus one. Next one, Cr2 plus is reducing in nature while with the same d orbital configuration. Mn3 plus is an oxidizing agent. Let us first see what is this d4 configuration. So Cr, atomic number 24, argon 4s1 3d5. So Cr2 plus argon 4s0 3d4. Manganese, atomic number 25, argon 4s2 3d5, Mn3 plus argon 4s0 3d4. Okay, so this is the configuration we have got. So what are they telling? Cr2 plus is reducing. So reducing means, okay, if it loses this one electron, okay, so if it converts this Cr2 plus, which has got the 3d4 configuration, and Cr2 plus in the Cr3 plus I2 antandre, then what it will be having? It will be having the 3d3 configuration. In 3d3 antandre, we have got 3 electrons, okay, in the T2G level. Okay, so that is half filled orbital. Half filled orbitals or extra stable. Okay, so T2G orbital nalli adu extra stability na kodtirodrinda, so what happens is Cr2 plus easy agi it will act as a reducing agent. So immediately it will lose an electron and become Cr3 plus. Whereas in the case of manganese, what will happen? Even this is also having 3d4 only, but it is an oxidizing agent. So because oxidizing agent andre this one, immediately it will try to convert into Mn2 plus from Mn3 plus. So Mn2 plus agid takshana enagutte, it will become 3d5 configuration. Okay, so again 3d5 is the off filled orbital. Okay, so hence it is more stable. So hagagi illi Cr alli Cr2 ಇಂದ Cr3 ಆದಾಗ ನಮಗೆ T2G ನಲ್ಲಿ ಹಾಫ್ ಫಿಲ್ಡ್ ಆರ್ಬಿಟಲ್ ಸಿಗುತ್ತೆ, ಹಾಗಾಗಿ ಅದು ರಿಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗಿ ಆಕ್ಟ್ ಮಾಡುತ್ತೆ. ಸೊ ವೆರಾಸ್ ಇನ್ ದ ಮ್ಯಾಂಗನೀಸ್ 3 ಪ್ಲಸ್ ಇಂದ ಮ್ಯಾಂಗನೀಸ್ 2 ಪ್ಲಸ್ ಆದಾಗ ಇಟ್ ವಿಲ್ ಅಕ್ವೈರ್ ದಿ ಹಾಫ್ ಫಿಲ್ಡ್ ಡಿ ಆರ್ಬಿಟಲ್ ಸ್ಟೇಟ್. ಸೊ ಹಾಗಾಗಿ ದಟ್ ಈಸ್ ಮೋರ್ ಸ್ಟೇಬಲ್ ಫಾರ್ ದಿ ಮ್ಯಾಂಗನೀಸ್. ಸೊ ಮ್ಯಾಂಗನೀಸ್ 3 ಪ್ಲಸ್ ಇಸ್ ಅನ್ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್, ಸೊ ವೆರಾಸ್ Cr2 ಪ್ಲಸ್ ಇಸ್ ಅ ರಿಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್. ಬಟ್ ಎರಡರಲ್ಲೂ ಕೂಡ ಡಿ ಆರ್ಬಿಟಲ್ ನಲ್ಲಿ ಈಕ್ವಲ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ. ಬಟ್ ಅಟ್ ದ ಎಂಡ್ ಆಫ್ ದ ರಿಯಾಕ್ಷನ್ ಯಾವ ರೀತಿಯಾದಂಥ ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತೆ ಅನ್ನೋದ್ರ ಬೇಸ್ ಮೇಲೆ, ಸೊ ಇಲ್ಲಿ ಒಂದು ರೆಡ್ಯೂಸಿಂಗ್ ಆಗತ್ತೆ, ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗಿ ಆಕ್ಟ್ ಮಾಡತ್ತೆ, ಇನ್ನೊಂದು ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗತ್ತೆ. Next one, metal bonding is more frequent for the 4D and 5D series of transition metals than that for the 3D series. Okay, so 3D series antandre 4th period, 5th period, 6th period, 4D, 5D respectively. Okay, so ee element galalli irtakanta metallic bond na avaru compare ಮಾಡ್ತಿದ್ದಾರೆ. So they are telling that so the metallic bond is stronger in case of 4D and 5D compared to 3D series anta. So what would be the reason for this one? So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, 4D 5D series ನಲ್ಲಿ the distance from the shell, that is ಈಗ ನಾವು 3D elements ಅಂತಾನೆ ತಗೊಂಡ್ರೆ 3D elements are there in the 4th shell. Okay, 4 shells are there. So ಆ 4 shells ಇಂದ ನಮಗೆ S ಇಂದ ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಮಾಡಬಹುದು ಅಥವಾ 3rd ಶೆಲ್ ಇಂದ ಕೂಡ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ರಿಮೂವ್ ಮಾಡಬಹುದು. ಬಟ್ 4D and 5D series ಅಂತಂದ್ರೆ 5 shells and 6 shells will be there. So here 5 shells and here 6 shells will be there. So the distance from the nucleus to the last shell would increase in case of 4D and the 5D series element. Okay, so because of that reason easiಯಾಗಿ electron remove ಮಾಡಬಹುದು because lesser the nuclear charge compared to 3D lesser nuclear charge will be there. So ಹಾಗಾಗಿ electron ನಾವು ಈಸಿಯಾಗಿ remove ಮಾಡಬಹುದು and more electrons are coming out ಅಂತಂದ್ರೆ the positive kernels whatever will be formed. Okay, so that interaction with the electron is greater, that electrostatic force of attraction. So more the interaction, stronger will be the metal bond. Okay, so this is the reason. That is, they have got their electron of outermost shell at the greater distance from the nucleus, so as compared to 3D transition elements. Next one, transition metals and their compounds generally exhibit a paramagnetic behavior. Paramagnetic behavior antandre, so they should get attracted towards the magnetic field. So a magnetic field ge attract aglike they should have the unpaired electrons. Okay, so unpaired electrons idre matra they will get attracted towards the magnetic field. They are called as the paramagnetic in nature. So in case unpaired electron illa andre they are considered to be a diamagnetic. Okay, so in transition metals nalli the definition itself will tell that this should have, I mean these metals should have partially filled d orbital. ಅಂದ್ರೆ ಅಟ್ಲೀಸ್ಟ್ ಒಂದು ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇರಲೇಬೇಕು ಅಂತ ಅದು ಹೇಳುತ್ತೆ. ಈಗ ನಾವು ಕಾಪರ್ ಅಂತ ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡ್ರೆ Cu2+ ನಲ್ಲಿ ಮೆಟಲ್ ನಲ್ಲಿ ಇರಲ್ಲ Cu ನಲ್ಲಿ, ಬಟ್ Cu2+ ದಿ ಅಯಾನ್ ಅಂತ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಸೊ ಅಟ್ಲೀಸ್ಟ್ ಅಯಾನ್ ನಲ್ಲಿ ಪಾರ್ಷಿಯಲಿ ಫಿಲ್ಡ್ ಡಿ ಆರ್ಬಿಟಲ್ ಇರುತ್ತೆ. ಸೊ ದಟ್ ಮೀನ್ಸ್ ಇಟ್ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ದಿ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್. ಸೊ ದ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ವಿಲ್ ಮೇಕ್ ಇಟ್ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್. ಸೊ ಡೆಫಿನಿಷನ್ ನಲ್ಲೇ ನಮಗೆ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರಬೇಕು ಅಂತ ಹೇಳೋದ್ರಿಂದ ಆಬ್ವಿಯಸ್ಲಿ ದೇ ಆರ್ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ in nature. So the strength of that paramagnetic nature is depending on the number of unpaired electrons present. So ಕೆಲವು ಯಾವ್ದ್ರಲ್ಲಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಮ್ಯಾಂಗನೀಸ್ ಅಲ್ಲಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ, and even iron also will be more. So depending on Fe3+ ions. Okay, so depending on the ion they have given, so you have to calculate the number of unpaired electron and tell which has got the more paramagnetic nature. Next one, which metal in the first transition series exhibits +1 oxidation state and why? So first transition series and they're talking about the 3D series. So from there scandium in the zinc organo we have to analyze here. So you have atom nalli +3 oxidation state exhibit ಮಾಡುತ್ತೆ ಅಂತ, sorry +1 oxidation state. So scandium +3, next titanium or vanadium, chromium and all like +2, +3, +4, +5 like that it will be there. So when it comes to copper it will exhibit +1 and +2 oxidation state. So copper will exhibit this oxidation state, that is +1 oxidation state. The reason behind that was because of its electrons. 3D 10 4s1 irutte. So when it loses this one electron from the outermost shell, then it will be having the 3d10 4s0, and this is the copper ion. Next one, Se3+, V3+, Ti4+, and Mn2+, which forms the colored solution. Okay, so among these ions we have to find out scandium. Atomic number 21, so -3 electrons, so it will be having 18 electron. So here no d electron, so 0 d electrons means no d to d transition, so it is colorless. Vanadium 3+ ತಗೊಂಡ್ರೆ, so vanadium is 23. So 23 nalli we are removing 3 electrons means 20 electrons will be there. So that will be having so 4s0, 3d nalli 3 electrons ittu, adralli 1 electron, still 2 electrons are there, so 2 d electrons, that means it is colored. Next, titanium 4+. Titanium 4+ nalli again it is 22 atomic number, so there we are removing 4 electrons, so it will become 18. So again 18 means 0 d electron, so it is colorless like that of the scandium. So Mn2 plus, it is having 25 electrons minus 2, so it still be having 23 electrons. So 4 is 0, 3d 5. Okay, so 5 unpaired electrons will be there, and hence it is colored. Okay, so these 5, okay, so this orbital, this is how it will be present, so we can see colored. Next one, highest oxidation state of a transition metal is usually exhibited in its oxide. Okay, so what will happen is usually these transition elements will either combine with the oxygen, or sometimes it will combine with even the halides also. So halides or oxygen, both like fluorine na tagondre halides alli and oxygen na tagondre, we know that these are electronegative atom. So because of their strong electronegative nature, the cationic nature whatever been exhibited by the metal, adanna easy agi compensate ಮಾಡುತ್ತೆ. So ಹಾಗಾಗಿ the highest oxidation state of the transition metal, so ಯಾವಾಗಲೂ oxide ಅಥವಾ even sometimes fluoride also will get exhibited. Okay, so because of their oxidizing power ಅಥವಾ more electronegative nature of electronegativity, and they have got the low ionization energy, that is the these metal transition metals will be having the low ionization energy and smaller the size, and the anions are more electronegative, hagagi their oxidation state is stabilized. Next one, describe the general trends in the following, that is the 3D elements nalli iden trend ide anta navu baribeku. So the oxidation state, what will happen? Oxidation state will increase till manganese, that is middle of the series orgunu increase agate, then it will decrease. Okay, it will increase and starts decreasing. So starts increase up to 7, then it will decrease. Next one, both oxygen and the fluorine stabilize high oxidation state. Just now we learned because of their high electronegative nature, they stabilize the higher oxidation state. But oxygen andre oxide stabilize ಮಾಡುವಷ್ಟು fluoride stabilize ಮಾಡಲ್ಲ ಯಾಕೆ ಅಂತ ಕೇಳಿದ್ದಾರೆ. The ability of oxygen to do so exceeds fluoride. Okay, so what is the reason? The main reason for this one is maybe fluoride is more electronegative than oxygen, but what will happen is oxygen can form the multiple bond with metals. So because of this reason, the oxides are more stabilized than the fluoride molecules. Okay, so because oxygen is more electronegative also, at the same time it can form the multiple bonds also. Okay, but fluorine cannot form the multiple bond. Last question, what are transition elements? Write 2 characteristic transition elements are elements, d block elements, which are having the partially filled d orbital, either in their oxidation state, one of the oxidation states, or in the atomic state. Okay, so what are the 2 characteristics of transition elements? They exhibit variable oxidation states, and they are good catalysts, so they have got the catalytic nature, and they can form the complex compounds also. Coordination compounds can be formed because they have got the partially filled d orbital, and easily alloys can be made, easily even the transition in interstitial compounds can also be formed. Okay, So these are all any two characteristics we can mention for the transition elements. Okay, so this question answers helps you to answer. Thank you so much.